My name is Ben Cohen. I'm a product marketing manager, and I focus on edge computing. So edge computing with OpenShift, edge computing with Microshift. Today, I'm joined by Mark and Matt, and they're going to talk about image mode, which is it's a new approach to OS deployment. So it lets you build, deploy, and then manage both RHEL standalone hosts and OpenShift nodes. So with that out of the way, I'm going to pass the ball over to Mark to kick things off. So Mark, off to you.
All right, thanks, folks. Hey, everybody, I'm Mark Russell. I'm a product manager at Red Hat. I work on the OpenShift and RHEL product management teams, and I have with me Matt Micene, who's a technical product marketing manager who works on RHEL, and in particular, lately, image mode for RHEL. So bottom line up front, we are shipping RHEL as a container image that you can customize and deploy with industry standard tools that you probably already have in your environment. It's a simple concept, but we're going to get into why it could have a profound effect at the way that you think about your infrastructure. Some of what you're going to talk about is going to be familiar to close followers of RHEL CoreOS, and with good reason, because we've already implemented that concept, and we'll dig back in and show how that works into our roadmap. But first, I'm going to do a short intro. We're going to do a technical demo for the folks who want to see the real deal, and at the end, I'll tie it back to OpenShift. And I am not actually sharing any slide while I'm doing this, so let me get that going. All right. Okay, so let's go. Listed here, we have common challenges involving all sorts of IT problems, especially on the infrastructure side. If you look over the list, surely one or more, many of these may apply to you in some way or another. Oftentimes, operating systems can feel solved, but we see a lot of problems where organizations and technology meet. We have different sets of tools for different platforms, and we have a lot of challenges. And we believe that image mode for RHEL can bring incredible gains on every front here. If we go back in time, we go back far enough, if anybody remembers the days when we made handcrafted artisanal machines, and image cloning tools were a miraculous step forward, helped us capture and recreate systems. With virtualization, we got meaningful abstraction from the hardware, followed by image creation tools, which are quite powerful and view the OS through a different lens. There's a high amount of customization and a bit of complexity in terms of the creation and deployment. And then we have immutable operating system projects that Red Hat and other companies and communities have participated in over the years, and more exotic concepts like unikernels. All of these aim to reduce the maintenance, complexity, and time to value for your deployments. And the arrow of time here points towards more pre-configuration, more customization, and an immutable, or maybe even better to think of it as a repeatable and predictable state for your deployments. That brings us back to container images. This is an OpenShift crowd, so I'm going to keep it brief, but OCI containers have, as you well know, rapidly become pervasive in application packaging and delivering. This wave is happening faster than previous waves of virtualization and cloud. And in retrospect, it seems like a key aspect, and what won out was a very lightweight standard, the OCI container. The freedom and simplicity has made them completely ubiquitous. You can build them anywhere. You can deploy them the same software bits on your laptop, move it into production with fairly minimal friction. You can build pipelines as simple or as complex as your requirements. And this one building block has built an entire ecosystem around it. So after a decade of application containers, application teams are in many cases ahead of their infrastructure counterparts. Not all of them, but in general, we're seeing a ton of innovation on the application side, and we haven't quite seen that on operating systems over the same period. So we kind of thought, what if we, and by we, I mean admin types, what if we just joined the revolution? So image mode gives us a simple, consistent approach to managing the operating system from anywhere. The container file will set the from line to use a RHEL bootc image. And yes, bootc, that's the command that powers this. It stands for bootable container. And this image includes a kernel, a bootloader, and other items that you would typically exclude from an application container. We can add any application, software, agents, and dependencies that we need. We build the image and push it to a registry. At this point, we actually have to go through a process to convert that to a disk image, right? You need something to bootstrap the machine. That might be a VMDK for vSphere, a QCOW for KVM, an AMI on AWS, and so forth. So we're also can generate bare metal and do kickstart installs. We'll get to that later. And you could kickstart, a rack of servers from a container registry. What's really neat is that it's really the same process to do the apps after the deployment. It's the same build, promote, tag, and that sort of operational model. So your initial, there's no difference between your initial build artifact and your update payload. And not only that, you can use all the same, all the same infrastructure and standardize across the board, across footprints, using the same CI/CD pipelines that you already have, same container registries, security scanners, GitOps patterns, signing, attestation tools. You get my point. So let's look at like a kind of a pseudo example. This is, don't read too much into this, just sort of to give you an idea of what a generic example may be. Let's say I'm going to build a standard operating environment. I'm going to pull the RHEL bootc image, and I'm going to install all my dependencies, agents. I'm going to copy my configuration files over, and I may have some config scripts to run. And now I have my base image. You can think of that almost like, a container base image, just like an application team may have, they start with a base image like EBI or Alpine, and then they add their own standard, enterprise standard, tweaks to that, and use that as a base image. Likewise here. Now you can encapsulate the differences between the builds, and that might be differences between hardware or what line of business apps, what is required on different servers, whatever their personality is, right? You can encapsulate that in a series of builds. You can do multi-stage builds, or you can use, like here, a property, like kind of inheritance, where you're taking that, you're building your standard operating environment, and on the right, you're adding a database, and now you have your database image. For those familiar with the details of CoreOS, bootc is the evolution of OS tree, but it's now centered entirely on container images for customization and transport. Matt's going to show you the upgrades, but this is a good spot to note that while bootc is how it's all works, it's compatible with any container tooling, not just the ancillary stuff. If you choose another container build tool besides Podman, I'm going to be personally a little bit hurt, but it will work and it will be perfectly supportable. We wouldn't know. Real quick, before we get to demo time, there's going to be a few installation methods. I mentioned Anaconda. There's also a containerized tool called bootc Image Builder that converts the container to a bootable artifact. And bootc install, the command itself can install to a file system. That's a little out of scope for this demo. So let me just change shares here, and I will get to the terminal. Oops. There's the button. All right, so we are. Okay, so we're on a regular RHEL 9.4 box, as you can see. It doesn't have to be. I'm just happening to set up the demo on like this. Really could be, like you said, any Linux, any container tooling. I have a container file that I've created here. Oops, I'm not in the right directory yet. All right, and as you can see, I'm pulling the image. I'm adding a configuration file to Etsy Security, and I'm going to install a couple packages: QEMU guest agent and Vim, and then I'm going to enable the guest agent. But first we have to do something else. I need to log into my registry, right? If I try to Podman pull, let's do this right now. That's not going to work because I need to log in. I will show you a little trick. You can do Podman login and use your credentials to log in, and that will persist for the session. But on reboot, that file will go away. If you want to leave a persistent login, we can do it like this. So what I'm adding here is --auth file, and in my home directory and this path and this file name, and I missed one character there. That is you need to use that path. That's a path that that Podman is going to look for when logging in. Next, so and let me grab the password for that. And so let's see, on the Bling, this is a fish shell, and I'm using a tool called it's called Tide, I think. Yes, Tide is the fish plugin that made the shell Bling nice. Okay, so I've logged into, and so now I should be able to pull that image, no problem. Luckily, my downstream internet is pretty good enough that this shouldn't take too long. I cleaned out the system to make sure, just so you kind of get a vibe. Obviously, your connection, your data center may be a little faster, but this is fairly quick. I didn't have to pull this in advance. I could have just run the build, and the container file obviously tells the container engine what to build, but what to pull. But for demo purposes, I figured we'd do this step separately. All right. So now, like I said, let's look at that container file again, and let's build it. Oops. All right, so I'm pushing it. Oops. Yeah. Aha. Well, I'm just remembering that I've not logged into Quay yet. So I'm pushing this to Quay, and I'm going to do the same auth file, that login. And let me get my token here. And now we can, well, I didn't need that to build, but when we get to the push phase, we'll be glad that I did login. All right. So it's already got, it's already got quite a bit cached since I pulled it down. And so this will just be a process of adding a few more layers. I think them should be default. I don't really know why it's not. Not sure if I'm alone there. All right, so we've tagged it, and oops, and now I'm going to push it to Quay. Now this time, this was done in advance, so most of the layers are already there, as you can see, because it would have otherwise taken about 5 minutes with my upstream bandwidth. And once we get that up to Quay, Matt will be able to pull it down. All right, I will cede control. Over to you, Matt.
All right, so Mark mentioned earlier that we've got a couple of different ways to get this from the container image that Mark just pushed to an actual running machine. Since we are talking about standard tooling and making sure that we're using things that folks are familiar with and have existed for as long as I've been doing Linux since the 90s, we're going to use the very advanced and very, very new Anaconda method. Right? Anaconda is a way to pass arguments into kickstarts are a way to pass automated installs into Anaconda, right? Lay things down on disk. If you're familiar with Anaconda, tune out for a few minutes. Otherwise, I'm going to walk through this real quickly. So basically what we're doing here is we set up some basics about what our partitioning is going to look like I'm installing this to a virtual machine. Typically, and this is where the container that Mark just pushed to Quay, right? And this is the only thing he told me before we started today was where is this repo going to live? So hopefully I got that typed in right. Instead of where we would normally add packages and have a package list, we're actually just going to use this new OS tree container verb. This is the new thing that Anaconda has learned is how to unpack and pass these off to bootc. So there's bootc inside the process here. And then just like any other typical kickstart, we're going to go ahead and we're going to set up some services and firewalls. We're going to add a user. That way we can actually log in later. And this is our full kickstart. This is all we really need in order to get a virtual machine up and running from scratch. So let's go ahead and switch over to, this is my local laptop, right? So we're gonna sacrifice some bandwidth to the demo deities, and hopefully will work here. And all I've got is a bare virtual machine definition that is set up to go ahead and kickstart. And hopefully, let me see if I can catch that in time. All right, I need to scroll the screen just a bit. All right, so the only thing that we need to do here is to tell it where this kickstart file can be found. And I'm doing this locally over the network. That's what would be the Python module running the web server. That was just to provide a target for the kickstart file. And it helps to type correctly, otherwise we're here for a while. All right, so we're going to watch this boot, and this is just standard sort of installer kickstart. I started this using a standard ISO from 9.4 that I downloaded from the customer portal. So there's nothing fancy, nothing specific about the ISO that we're using either in order to get this up and running. It's currently doing the ISO check. It's now pinged the web server, and it's actually unpacking and pulling over that kickstart config. And we are now approaching the text-based install. All right. So far, so good. This means I've typed everything correctly so far now. Let's see what Anaconda thinks of our Kickstart file itself. All right, I didn't screw up anything there either. So we have a valid Kickstart file. It's understanding what it wants us to do, creating some file systems, and here we are. This is the magic, right? This is the new image mode deployment. It has started pulling. It doesn't put out a lot of output right here, but it has started downloading the image that Mark pushed from Quay. You use a Scopio on the back end to get it into the environment, and then bootc unpacks and helps lay it down to disk. So we are currently installing the contents of a container image onto a disk. And this will get us, as soon as we're done, this will get us the image that Mark wanted with all the software that we needed to install on my local machine with the username and password that I set up during the virtual machine creation. Yeah, that way we can go ahead and poke around just as soon as this is done. It takes a minute or two. Again, this is downstream bandwidth. Luckily, it's not terribly slow today. Oh, there we go. It's already done, and we're getting the bootloader, and it'll reboot here in a second. Right, it's doing all the typical things, making sure the subscription's attached and creating our user and whatever post-installation stuff that we needed to get done via Kickstart. Yeah, I can absolutely share that Kickstart file. There is nothing in particularly strange or complicated. I think I may have even pulled it from an example I found online and just replaced the packages section. All right, so rather than try to stare at this on a console, I'm going to grab that IP address, back over to my terminal, and log in with our super secret password. Right, cool. So, Mark, I think one of the things you said that was on here was, oh, did I get that wrong? Is Cause not on this demo?
Crucial tools I left out. Hang on. All right, let me grab back and let me fix that. This will let you take over from that. All right. Okay, so I'm gonna take back over, and yep, let's look at this container file again. Right. Okay, so the cool thing about the build environment, it's not a running system, so it's not doing everything, but we can do virtually anything in here. We can add repositories, we can move installed packages around. We're not going to do anything crazy today, but I did forget Cause and another utility I'm quite fond of, because I like to get right to things. I'll show you what I'm adding here, make that more readable. Okay, so first I'm adding a package that installs EPEL, Cause, as mentioned, and TLDR for those of us who find they get distracted in man pages. Okay, let me rebuild this. This is going to should go pretty quick, because we're only updating parts. We're only updating those last layers. Oh, did I? No, that should be good. All right, pulling down the EPEL metadata. You may have noticed in the container file we do a DNF clean all at the end. There's just no reason to include the metadata in the image. All right. So let's push those changes. So you can see how, especially once when you're iterating, it can become really quite rapid because the rebuilds. I mean, the slowest part here is simply that I'm uploading it. When you're rebuilding and iterating, it's really kind of a joy just because you can check things out very quickly. You can check things out without firing up a VM as well if you want to skip that time. There's a lot of things you can do. These are containers. You can run them as containers. Not what they're intended for, but if you need to check something out, make sure you save something correctly, you built it right, it's a real container. So I'll pull back again. Matt, I made my changes. Let's update.
Wow, Google Meet Resume actually works. All right, so what I've had here is this is the status command for bootc, so we can see that we're running that image from Quay, and I can go ahead and check for an update. So what this is going to go and do is this is saying, oh, there's we're tracking this particular image. right, which is the one that Mark just pushed. And it sees, oh, there's an image that is there, and we're actually going ahead and downloading just one layer, right? So it knows that there's only one layer that was changed in the image, so it's only going to download that one particular layer, not the entire image again, right? So now, if I look at the status command, what we see is we get this new block called cached update. And this tells us, well, the image is the same image, right? We're tracking tags here, so we're reusing that so we can update easily. But we do see there's a different child digest here, and we also see that this is we've got if we had a different version, say if we had a major version change to something else, we'd be able to see those things here too. So now that I've done that, I can go ahead and just reboot this system, and it will apply that change. Now I could have, if I wanted to, and didn't want to show you the status stage in between, I could have just run the boot C update command with the -- apply option, and that would have automatically downloaded and automatically rebooted that system all in one step. But for demo purposes, we want to make sure that we're showing these things. So what we now have, right, is we've got our booted stage, and this is now the new image with the new SHA that matches what the update was. And we now have a new section called rollback. Well, it actually was there before, it was just null. So if, for example, something had gone sideways with what Mark had updated, right, and I couldn't say, well, that's actually not my fault because I can't spell. If I couldn't run cowsay and say, or there was some incompatibility here that with the application we were supporting, we could actually roll back to the previous image, and that would also be as simple as a reboot, and it keeps all of the local state, right? And Mark, I don't know if you want to go into sort of the differences to remind folks of how OS tree state works, but those things that are local to the system would remain, and the only things that we're changing basically are those things that are pulled from the contents of the image itself for our updates and our rollbacks. So we now have a fully remote, right? Remember, this is running on my local machine. We did this over the interwebs to a public Quay repo. So this is fully updated and running now completely from Quay, and there's no need for this machine ever again to be reinstalled or have to go back through that initial deployment phase that Mark was talking about.
I was just going to add to the, not to keep hammering the build point, but the build portion of your image production and your tagging and whatnot, that can all be handled, like I said, wherever you want. I mean, that could be a GitHub action, a GitLab runner, whatever you're building images with today, which I know deep down is Podman. All right, so back to some slides real quick, and let me reshare a window. Oh yes, right, the one that says demo time. Okay, so real quick, we talked about Bootsy Image Builder and the formats. I just wanted to show this slide as well because of the fact that there is a plugin for Podman Desktop. You may be familiar with, there's an upstream open source project called Podman Desktop, and it has some plugins that make building multi-arch images and different output formats a snap. And before we get to OpenShift, I did want to say, if we look at, where do we see this fitting in? AI ML stacks come to mind right away. Right now, AI ML dependencies, frameworks, drivers need tight alignment, and yet they're also undergoing rapid change. So the ability to take all of those components and version them and tag them together is incredibly powerful. As things change, you're able to just replace the old image with the new without worrying about specific upgrade steps to get from point A to point B. For many purposes, it's going to be it's going to be like the RHEL use case, right? It's the app that is tied to the host, or that could just be a system agent, but there's something intrinsically that either your vendor hasn't containerized it and you don't want to, it's not containerizable, which is rare, but possible, and you want to marry them together. But what you get out of that is the fact that now you still get to take advantage of the tooling, the tagging, and the versioning, so you get some of the benefits of cloud native patterns, even for apps that are not suited for it. Edge appliances, there's really, I look at this as just a spectrum, and there's certain needs that are really, really crucial at the edge. They're not different in kind, really, than data center needs. They're just a little bit more intense. And so having that reliability, the upgrade reliability, and confidence that you're deploying identical system images is really powerful. And of course, container hosts. This makes a fine container host, whether you're running Podman or it's running Cryo under OpenShift. We are going to have all sorts of interesting options for how you lifecycle and bind your containerized app to your containerized OS to make that flexible. But we'll get into those details as they come along. For today, we are going to bring it back to OpenShift, where this concept was developed originally. So we started shipping RHEL CoreOS as a supported container image in OpenShift 4.13 last year. And everything about CoreOS layering is conceptually the same. Let me go back here and just say there is a slight difference. We're still using RPM OS tree in the back end, but they are based on the same code base, and we will be seamlessly migrating from one to the other. It's going to feel the same. So today, what we have is off-cluster layering. And in off-cluster layering, well, first of all, we're on an OpenShift cluster, right? So we have a lot of the tools that we need. We have build tools. We have all sorts of ways to trigger jobs. And on OpenShift, we also have a controller that we can use to reconcile machine state, and that's the machine config operator. So in this case, with the off-cluster layering, the administrator is responsible kind of owning maintenance of that image, right? They decide, I'm gonna update RHEL CoreOS. I'm gonna pull the image. I'm gonna build it with Podman or something else, and I'm gonna make my customizations, push that to a registry, optionally do some sort of testing and validation, and then you create a machine config YAML that tells the machine config operator to roll it out to the cluster. And I want to be clear, because I have heard sometimes people say that this is manual. Only the ownership of the image is manual, sort of the promotion of image. The rollout is still automatic. Once you tell the MCO that there is a new image, it's responsible for actually pushing it out to the nodes. But this is OpenShift 4, right? And we want to make things even more automated. We want the cluster to manage itself as much as possible. So instead of sending the container file to a build tool, we are going to put it in some YAML, of course, and we're going to apply it to the cluster database. Now OpenShift takes over. There's a new component called the Machine OS Builder. That's part of the MCO. And when you have automatic builds enabled, that Machine OS Builder is going to know that when there's a new version that you need to pull down the new version of OpenShift, rebuild, and roll out. In other words, think of it as the experience you have today, where when you run an upgrade, it upgrades the entire platform, the platform containers, the Kubernetes layer, the OpenShift add-ons, and the OS still get upgraded as a unit, as they have been. The difference is that it's automatically going to run a build. At this point, the administrator can put his feet up on the desk and wait, because until the build fails, there's nothing for an administrator to do. So what's next? We're going to make, as always, we want to make things better and easier. The key thing is to note is that today, layering on cluster is day 2 or only. So if you needed to put in a driver or an agent from that very, very first boot, that's something we're working on. It's going to continue to come out, probably tech preview towards the release of RHEL 9.5 later this year in November. what else? Like I said, we're going to be migrating. Should be absolutely unnoticeable, or in these very minor accommodations to move from OS/3 native containers to boot C. In the future, we're going to be looking at using ComposeFS and the FS Verity. I'm going to skip the details, but imagine I can almost use the word. I really can use the word immutable in good conscience here, because this would be a system image that even root access cannot touch. It's cryptographically validated and very difficult to write to. And we may be looking at a boot C native install path. Whether that takes the form of adding OpenShift, adding Anaconda as a potential OpenShift install path or not, we're still working on. We'd love your feedback and input. That concludes most of the words. Please check out the image mode landing page. There's lots of links to getting started. And we'll make the slides here available as well. And if there are any questions around now live, I'm happy to take them. Otherwise, please get in contact with us. I'm easy to find.
Yeah, awesome presentation. We really enjoyed it. Does anyone have any questions?
There was there was a question in chat, and I can talk about RHEL for Edge a little bit. That is the goal, right? The goal is that folks will still be able to use the RPM OS tree over the wire path in RHEL 9 for as long as RHEL 9 is out there, and the command itself is still going to be in RHEL 10, but for image mode, we are going to want to move towards, for Edge, we're going to want to move toward an image mode pattern. It absolutely fits. Boot C is the evolution of RPM OS tree. This is our path, and we're really committed to it across the board.
Is there just a follow up on kind of, it's more than just the Edge. Like, is there a path for folks that are kind of coming maybe from OS3 or the traditional like a blueprint and then generating images to like going to completely like boot C? Like today, I feel like there is some complexity, right, with image builder that we customers have, right? There's a lot of technologies they have to learn. So I was kind of wondering, as these new things sort of started to come up, like what's that journey look like, from a transition perspective?
I think we're still working on the details of how that's going to look. Arguably, you should really think about the configuration you have and put that into the build. Like we could look at doing an in-place upgrade, right, where you take that RPM OS tree system image and swap it with a boot C one, and it could be like bit for bit or package for package the same thing. But now you have this. Have you captured the config that you put into that RPM OS tree? So you just want to be thoughtful about how you do it. What we're encouraging here is moving as much of the config to the build process. So we'll probably have some flexibility in terms of, I know in general, boot C supports either, you can basically choose to, I think default is it will not replace etc files that exist on the disk, but you can choose to. If you want to version those etc files with the system image, you can have that overwrite every time. So this sort of, I'm kind of talking around it. I think the journey is assessing your configuration, and I think the best path is moving all of it into your container build. We're looking at what is going to end up in terms of blueprints, how much of that's going to be made use of with this path. Right now, certainly it looks like users and groups, but there's a lot still under discussion.
Cool. The other thing that I wanted to ask you guys is like one of the things that I was kind of brainstorming was like using like the developer hub, like to make it easier for folks to create like boot C images. Like is there any sort of thoughts around like kind of leveraging the backstage bit and like, so that you can go from zero to like a bootable container image quickly, with best practices and things baked in, right?
I mean, I know there's going to be a lot of work on the marketing side and the community side, making the standard. There's an initiative in the Fedora community. There are external communities that I recommend people check out, like Universal Blue and Project Bluefin. They actually use the RPM-OS3 native containers. Sorry, wait. Can you, Rob? Can you go back and give me the beginning of your question, because I lost my train of thought.
I was just saying, like to make it easier for folks to like go to an image, right?
Yeah.
Bootable image, like other tools that probably like things like Backstage. I guess maybe that's something that you'll expect the community to sort of take it forward.
I'd like to see and this is actually, I think, what I wanted to get at. Like Universal Blue already, all of their build stuff is online and can be checked out. I think they're a great example. I'd like to see a culture of sharing the container files. I'd like to come, if anybody has any ideas for a catchy name that's like Bootsy container file, something better than that, but
like a catalog, right? Like a catalog.
Yeah, catalog. I mean, it's funny. What I had thought of so far was like, maybe asking for a file type on Artifact Hub, something like that as well, for community container files. I think that would be. It makes a lot of sense to share the actual build files over the images, and I think that's the way we want to go. But yeah, let's follow up. I'm curious. It'd be interesting to work that into some of the developer tools. It'll be, we may end up going just on, like you said, community demand and interest.
Got it. Thanks. Good stuff, by the way. Really enjoyed it. Cheers.
Thanks so much.
Mark, does your process change the concept of a trusted image in any way?
Well, we're going to take a lot of, we get, how to say, yes, is the short answer. The longer answer is we get to take advantage of all the breaking container provenance and attestation tooling that is coming out, right? Because they're container images. So we are going to be SIG-store signing and SIG-store validating these containers. I think other attestation things like Keylime and Trusty are going to be down the road on the roadmap.
Okay, Matt, you have your hand raised.
Yeah, I just wanted to chime in because I know this is the ideas here, right? For y'all are much more container savvy than the typical infrastructure folks that I represent, right? So I think one of the things to highlight there is that actually provides your infrastructure folks with a concept of a trusted image, right? We don't really have a way at the moment to have a attested, signed gold image that we can say, yes, we know the provenance from zero to running virtual machine, right? A lot of that today is it's GitOps for the config, not necessarily GitOps for the actual binary artifact that you're installing on the system. So there's a lot of things in the container world that just don't apply and can't apply to a system image in the same way. And we get a lot of those things that we can now say, in the same way that you have a trusted application container image, we can say we have a trusted system image as well, or a combined system and application image that we know exactly, precisely who built it, when, where it came from, when it was updated, and we can trace that back with an actual chain, as opposed to saying, yeah, we're pretty sure we ran these scripts and they ran right, so it should be good and these won't drift, right?
Okay, awesome. In your opinion, is there, with Podman doing more of this, is it less for Scopio and Buddha to do? Are we not going to be using those as much in the future?
They just have different use cases. Builda and Scopio tend to be used more in scripted and pipelined environments. There's also some special magic things that, like Builder can build containers without a container file at all. There's certain things that it does, and they share a lot of code. So no, the future is Builder and Scopio will remain for their use case. I think for most folks, Podman does it all. It's the Swiss Army knife. It pushes, it pulls, it builds, it runs. So most people don't. Certainly hands-on developing, you really don't need anything else.
Do we have any other questions? Ben? Okay.
And thanks, Matt, by the way, for mentioning in chat that I'll just say for the record, for folks still in the recording, this is Tech Preview.
Yes. Well, this was an amazing presentation. I certainly learned a lot, and I think our community would definitely benefit from this. So we thank you, and we would love to welcome you back again for the next updates.
Well, thank you, folks, so much. We really appreciate coming on, and anybody who's spent time listening to it, appreciate your time as well. Thank you.
Thank you.